Hello and welcome back. As we have discussed, we are going to start this entire series from absolute scratch. There are no prerequisites to understand Java. I'm going to start the journey from how programming came. To start with, programming came into picture with one of the greatest invention which happened in 1940s, which is called as transistor. Because of the invention of transistor, entire world reshaped. The way we work is changed. What is the impact of transistor? We will try to understand. For now, to start with, if I ask you which is the most important component in a computer, these days computers are in different form. Your mobile phone is a computer, your laptop is a computer, your desktop system is a computer. In that device, which is the most important component? If I ask you, the answer must be CPU, or you can say the processor, microprocessor. This is the most important component. Whatever is happening on your phone, in your mobile phone, in your laptop is because of this processor. It is the brain of this entire device. And this processor I would be representing in this style. Let me represent the processor here. And one information about this most important component you must understand. It is of one technology called as semiconductor technology. One of the most important technology, which is semiconductor technology. Now, do we need to learn more on the semiconductor technology? What exactly it is? Any device any technology device which is being manufactured using the transistor is referred as semiconductor technology device. If I say this processor is of semiconductor technology device, that means to manufacture this processor, behind the scene transistors are used. Great. Now what are the transistors? Do we need to learn something about it? Nothing except one thing you must know about transistor. Transistor is such a device which understand only two things, either low voltage or high voltage. I have said that this processor, the most important component of your computer, of your device, is of semiconductor technology. That means to manufacture this processor, transistors are involved, and transistor understands only two things, either low voltage or high voltage. Low voltage means 0 volt, high voltage means 5 volt. And all these terminologies are hardware terminologies, electrical terminologies. We are here to become software engineer. From being a software engineering, if you want to see from the perspective of being a software engineer to the same concept, you have to look in a way that the processor, the most important component of your machine, is of semiconductor technology device. That means to manufacture this device, behind the scene transistors are used extensively. Great. And transistor understands only two things, low voltage and high voltage. In software engineering, low voltage and high voltage is represented by 0 and 1. Now the conclusion is, the most important component of our machine, of our device, understands only two things, either 0 or 1. Why two things? Because this component is of semiconductor technology. That means behind the scenes transistors are involved to manufacture. That means transistor understands only two things, low voltage and high voltage. That means the processor understands either 0 or 1. Now we could able to manufacture this device so that it can do something to us, something for us, right? To help us, to make the things easier for us, to process something which we wanted. And it is a dumb device. It cannot do something by itself. You have manufactured this wonderful processor, and if you want it to do something for you, you have to instruct, you have to tell. And how do I tell? How do I instruct? In a way it understands. Now all of you are able to understand English, so only I am communicating in English. If you could able to understand Kannada, I will talk in Kannada. If you could able to understand in Farsi, I will talk in Farsi. Fine. Now processor understands only one thing, either 0 and 1. And I want my processor to add two numbers for me. I have to tell in a way it understands. For an instance, if I want my processor to add two numbers, I will write the instructions in this style. This is not the exact code for adding two numbers. This is just an example. Maybe I want my processor to subtract two numbers for me. I will tell in a way it understands. I want my processor to multiply or maybe do some task for me. I will communicate to processor in a way it understands 0, 1, 0, 1, 0, 1. Fine. Writing instructions in a form which your machine understands, we also call it as machine level language. Machine level language, or you can say binary code. Fine. In a way which your machine understand. And now you can see this is for addition, this is for subtraction, this is for division. Writing multiple instructions in one place, set of instruction in one place, is also called it as program. Program is writing multiple instruction. I am instructing you to do something. Please open your book. That is one instruction. Now writing addition, add two numbers, subtract two numbers, multiply two numbers. Writing set of instruction in one place is called as program. The concept of programming came into picture. Now this set of instruction, if I give it to my processor, will it understand? The answer is yes, it will understand, because processor understands only two things, 0 and 1. And the way you have communicated to processor is in the form of 0, 0, 1, 1. Now 100% you will be getting the output. Great. And this style of programming, initially people were very happy that yes, we could able to manufacture a device. If we are instructing something, it is doing something for us. I hope you are able to understand this. But this style of instructing, communicating with processor is not human friendly. Imagine if you want to develop a big application, how many zeros will you write? How many ones you will write? 0, 1, 0, 1, 0, 1, 0, 1. And if there is a small error, will you be able to rectify? Which 0 you will rectify? Which 1 you will rectify? Fine. Hence, the programming people started to evaluate. They tried to experiment with different types of instructions. Mnemonics came into picture. Similarly, after some of the evaluation around the 1960s, as a human, we came to a conclusion that we can write instructions to our machine using the symbols and English-like commands. Symbols means plus, plus means plus, minus. These are the symbols. Or English-like commands. Print means print. Scan means scan. If means if. Right? Writing the instructions, programs in English-like commands and symbols, human understandable format, we also call it as high-level language. Now, if I write a program using English-like commands, print, scan, if, else, and all these symbols, and if I give it to my processor, will my processor able to understand? No. Processor says, get lost. I cannot understand. I have been manufactured by humans. You have made me, you have manufactured me using transistors. That means I understand only two things, zeros and ones. And whatever you are telling me, plus, minus, print, scan, if, I will not be able to understand that. I cannot do something for you. For which humans, again, we created one system software. Name of the system software is compiler. Name of the system software is compiler. What is the duty of compiler? It will convert your high-level language code, the instructions, the program which you have written in English-like commands to zeros and ones. Machine understandable format, binary code. That's the duty of compiler. Compiler is a system software which will convert your high-level code, whatever you have written using the English-like commands, into zeros and ones. Machine understandable format. Now, this machine understandable format, if I give it to my processor, will it be able to understand? Yes, it will be able to understand. Here is where the concept of coding, programming came into picture. And that's why we have to compile every time we write the code. We do write, we have to compile. Please do compile. Right now, most of the IDs, we have the concept of auto compilers. The moment you write the code, automatically it will get compiled. How Java exactly works, what is the execution flow of Java, we will understand. This is just the start, how programming came. From 1960s, even today in 2024, we are writing code in English-like commands, irrespective of the programming language you are using, whether it is print, scan, C language, C++, whatever programming language you are using. We are writing the code in English-like commands, print, if, else, scan, right? But our processor understands only zeros and ones. Even today, processor understands only zeros and ones because processors are being made using transistors, and transistor understands either low voltage or high voltage, which is 0 or 1. So at the end of the day, whatever language you write the code, at the end of the day, it is reaching to processor in the form of zeros and ones. Hence, we come up with the concept of compilation interpretation. Fine. I hope you could able to understand this fundamentally. More on this, we will understand moving forward what is the execution flow of Java programming language, how it could be different from any other programming language, what happens behind the scene. From the scratch, we will try to see. Now, if you could able to understand this entire video, please make sure to like the video. Please do comment, share with your colleagues who want to understand coding. If they have phobia of coding, I can make sure that this entire series, your phobia will go away. You will be pro in Java. If you have fear of coding, you feel that coding is not for you, this is the right place. And I can assure you that you will be pro in coding, you will be pro in Java. Confidently, you will be in a position to code and also use Java for the development also, whenever you are writing a logic in DSA or for any other purpose. Fine. So thank you so much for joining me in this video. We will meet in the upcoming video and try to understand more on Java in the most simplified possible way.